last video I was discussing some new method of deriving HCF. In case there are two numbers given, just let me remind you the numbers. That the numbers I have taken is 64 and 85. I have taken difference of this 85 minus 64, which is equal to 821. Now, as per the definition, it says if the two numbers are given whose HCF has to be calculated, then I will take the difference of these numbers, and the number which as a result what I will get, if it is a perfect divisor to these numbers, then this number itself is a HCF of the numbers given. Now up to this, okay. Now in case some situation may arise where this difference is not a perfect divisor. Let's say the example of the same 84 and 102. If I take, I will get the difference is 102 minus 84, that will give you 18. Now if I try to divide 84 with 18, it won't give, because 18 7 4s are 72 and the remainder is 12. So that is not a perfect divisor of 18. Divisor of 18. Sorry, on the other hand, 18 is not a perfect divisor for 12. And the same thing, if I do it 102, this also will not give you, because 18 5 is 90, and in this case also the remainder is 12, that cannot be divided with 18. So what would this case I will derive it. So there the same, the one more extension of that theory is there. If the difference is such that if I take the factors of this, so what would be the factors? 2 would be the factors, 6 would be the factors, 9 would be the factors, and here 18 also would be the factors of 18. So all these are the factors of 18. Out of this, anyone, if it is perfect divisor to this number, sorry, I will have the upper one. So if out of these factors, if anything is a perfect divisor of this number, then that would be the HCF. So in first case, if difference directly a perfect divisor, then difference itself a HCF, or otherwise if the difference is not a perfectly divisor for this number, I would take the factors of that difference, and out of this which one is perfect divisor for this number, that would be your HCF. Now try with these numbers. Now 18 is almost not, so I will not try it, because this is the difference I have achieved. So 18 I have already discarded. So try with 9. If I try with 9, there is no multiple of 9 will reach 84. So 9 could not be a solution. So if I take 6, 84, that means 6 here, 2, 4, 6 4s are 24. So this is an integer. So 6 is a perfect divisor. So I try with 6, 102. It will give you 6 1s are 6, 4, 2, 6, 7, 42. So this is also an integer. So 6 is a perfect divisor for this number. So 6 would be the HCF. So here 6 is HCF for this. So I think you have understood the concept of calculating or deriving HCF for any numbers or multiple numbers, any two numbers or multiple of more than two numbers. Okay. So there is one more relation that can be faced, that the product of the numbers is equal to LCM product HCF. So that means if I have given any two numbers for which your LCM and HCF has to be calculated, then if I take the product of those numbers, whatever the result I will get, if I multiply the LCM and HCF of those number, then if I take the product of those, that will give you same result. Let me check with the small example. If I want to make 6 and 8, if this numbers is given, so 6 and 8, your 3, 4. So for this case, your HCF is 2 and LCM is equal to 2 3 is 6, 6 4 is 24. Okay, so this will be your LCM. Now the product, multiplication of product, I will get 48. Let's see, the product of LCM, HCF and LCM is how much? 48. So these numbers are equal. So this theory is holds good for this number. Let me try with another number. I try some bigger number, 24 and 72, let's say. So if I calculate 12, 36, then again 2, 6, 18, 2, 3, 9, 3, 1, 3. So 3 to the 6, 6 to the 12, 12 to the 24. So 24 is HCF, 24, and multiply 3, that means LCM is equal to 72. So now you can see that the LCF and HCF is the same number, is the same result as of the numbers. So definitely if I multiply 24 72 and I multiply HCF and LCM, it will give the same result. So I need not to show you the calculation because those numbers are same. Okay. Now, is it applicable for more than 2 digit? Okay. So let me check that also with an example. If I take 6, 4, 6 and 8, I am taking small numbers to ease the calculation. So let me check. So this will not follow the rules. So rather I will follow the other rules. It will give you 4, 2, 4. That means 2 to the 4. So 2 here, 2 the next number, 2, 4, 8. So HCF is equal to 2. And what would be the LCM? LCM I will do it by factorization method. 2, 3, 4, 2, 1, 3, 2, and this. So this is LCM is 2 to the 4, 4, 3 is 12, 2 to the 24. Okay. Now that LCM or HCF is equal to 48. If I multiplied all these three, 4 into 6 into 8, I will not confine with this result. So definitely this is true only for 2-digit number, not more than 2 digit. So this is the limitation for this theory. So the product of the numbers, here you have to mention product of 2 numbers, not more than 2 numbers. So you can directly write product of 2 numbers is equal to the LCM HCF of those numbers. So this will complete the statement. Okay. So this is for now. I will come with one more concept, or you can say more theorem of a particular mathematician who has derived some theorem on basis of his idea, and that is a perfect one. So I will definitely describe, and along with that some types of different numbers that I have expressed in my earlier videos, that I will also add up with that. Thank you for now. Keep watching and please subscribe my channel.